Hey there, everybody. This is going to be part 2 of the Firewall Objectives Review for the RHCSA. Now, a large part of today's demo is going to be centered around the various zones of firewalld. So let's talk about that for a moment. Alright. What I'd like to do first is map out the default zones in firewalld on what I guess you could call a spectrum of some sort. That way, it'll be a little easier to remember the general roles of each zone when it comes to how trusting they are. You'll see here that I've put zones designed for low trust environments on the left-hand or red side, and that would include the block, drop, and public zones. So that makes sense. And in the middle, I put zones like DMZ, external, and internal. And the reason for that is because these zones are commonly used on the border between a low trust environment and a more trusted environment. And finally, over on the green end, or the right side, are going to be the work, home, and trusted zones, because we use these zones when we really trust the surrounding machines on our network. Okay? Next, I'd like to show you a general description of the zones. Here they are. And you can feel free to pause the video and take a closer look at these if you'd like, but I'm just going to summarize it for you. The big idea here is that all of the zones, except the trusted zone, have the default behavior to block incoming traffic, unless there is an explicit exception made. We've also explored in the last video how the block and drop zones take that a step further by returning an ICMP error or even outright ignoring traffic when it's disallowed, right? And for the other differences between the zones, that'll just be up to what they're intended to be used for and what services and features are enabled out of the box. Like, for instance, the internal and external zones are commonly used for a machine that handles routing traffic from an internal network to an external one, and vice versa. And in fact, the external zone has a nice trick up its sleeve by having masquerading enabled, which is what allows it to handle network address translation. Now, another more relatable example might just be the home zone, where services like Samba Client are allowed by default. Okay, moving on. When it comes to the trusted zone, this is a really special one. It has the default target to accept all inbound traffic. And with that being said, you should really only direct your traffic to this zone if you absolutely do trust that traffic, because I mean, that's the whole point, that's what it's for. So I hope that's clear. And it's also worth pointing out this thing that I mentioned here at the end. All of the zones allow you to make outgoing requests by default. An example of outgoing traffic might be like browsing the web, stuff like that. However, what I want you to know is that if you wanted to do something related to this, like block a machine from connecting outbound to a specific IP address, and you might want to do that so people can't access a specific server on the internet, like blocking websites. Well, if you want to do that, you're going to likely need a rich rule. So just keep that in mind. That's going to be a little out of the scope of this video, but I just wanted to bring that up. Okay, cool. That was a nice little review of that. And now what we'll do is get back onto our machines. It'll be the same ones as last time, and we can start with changing the default zone. So you'll see here that I'm on my app server 3 machine, and if I run a firewall-cmd-get default zone, we're going to find that my default zone is the public zone, which is in fact the normal behavior for firewalld out of the box. However, we can change this default zone with the set default zone option, which I'll show you in just a moment. But let's just first check what zones we already have available with the firewall-cmd-get zones command. Okay, so that output looks pretty familiar, right? It's about the same thing that we just looked at. One thing that I'll just point out here, though, is this NM shared zone right here. This is a zone used internally by Network Manager. I just wanted to bring that up because I didn't mention it before, but I just want to focus on the standard set of firewalld zones. We're not going to worry about NM shared. Okay? So now, if you wanted to set your default zone to something else, such as the home zone, we can use the following command, firewall-cmd-set default zone equals home. and I can just hit enter here. I don't need to put /permanent, and that's because this is something called a standalone option, so it's going to take effect right away. I can demonstrate that by just doing a get default zone, and it says home, and I can even do a firewall CMD reload and do a get default zone again, and it's still going to say home. Yeah. So anyways, if I go ahead and do a firewall CMD list all, what I want to show you is that in the home zone, we have a couple of more services allowed, such as the Samba client, which I mentioned earlier. Cool. So with that being said, let's move into something that I think is really important. Let's explore how the default zone setting differs from active zones that have interfaces explicitly assigned to them. And what I mean by that is, if we outright changed our active network interface to a different zone than our default zone, then the real work, the real business going on is going to be done by the active zone with the active interface assigned to it. While at the same time, our default zone, whatever it might be, if it doesn't have an active interface already assigned to it, it's going to be sitting around waiting for a new unconfigured interface to come along. So like that could be adding a network card to our machine, something like that. And then it'll get auto-assigned to that default zone. So I mean, this is an important distinction to be aware of, because if you have an interface assigned to a different zone than your default zone, you might be scratching your head as to why the settings on your default zone aren't taking effect the way you expect them to. Or worse, you might not even notice that there was an issue to begin with. So how about I just give an example of how that works so we can better grasp this? What I'll do is switch over to app server 2 this time, and I'm going to do a firewall -cmd --list all over here on my default zone. And you'll see that my current and only active interface right now, ENP1S0, is under the public zone, which is also the active zone right now as well. And I mean, I can also check that with firewall CMD get active zones. We'll get very similar information like that. But here's the thing. I never explicitly told firewalld to use this interface in any zone. Firewalld just assumes that if I don't say anything otherwise about what zone this interface should belong to, it's going to follow along with the default zone. And we saw that on app server 3, remember? I just changed the default zone to the home zone here, and its one and only network interface followed along with it to the new default zone. See? So with that in mind, I'll go back to app server 2 here, and I'm going to change the zone of my interface with a firewall -cmd --change interface equals ENP1S0, and then I'm going to set the zone to something else, like, I guess, work. Sure. And I'll do this in the permanent configuration with a --permanent. There we go. And so it says that the interface is under control of Network Manager, but it's still going to do what we told it to, so that's fine. And now I'll just do a firewall CMD reload. And now this interface will be handled by the work zone. So I can run a firewall -cmd get active zones. And you can see here that my interface is now part of the, or handled by the work zone. Okay. However, if we check again, remember that my default zone is public right now. So if I decide to change my default zone to something else, like, I guess, the DMZ zone, with the firewall CMD set default zone equals DMZ, and I guess I could reload as well, why not? What we're going to find is that my active zone is still going to be the work zone with my interface. And this is happening the way it is because I explicitly told firewalld to assign my NIC to the work zone, so it's not going to budge from there. Now on app server 3, I didn't make any explicit changes, so the active interface follows along with whatever the default zone is going to be. I hope I made that crystal clear. Now let's just go over a couple of things. One is that I'm going to add a network card to this app server 2 machine real quick, and I want to show you that it's going to get assigned to the default DMZ zone when I bring the machine back up. Okay, so just give me 1 second while I do that. Okay, I'm back, And now, if I run something like IP adder, what we're going to find is that my new interface is indeed available, ENP8S0. That's good. And what I want to show you is that if I run a firewall-cmd -list all on my default zone, that, well, there we go. My new interface is under the default zone, which is DMZ in this case. And that's because I added this NIC to this machine without giving any further instructions to firewalld. So I hope I made that easy to understand how that works. And anyways, remember how my other interface is part of the work zone? So we can just confirm that with a get active zones. And yep, it's part of the work zone, ENP1S0. Well, what if I remove it from the work zone by doing a firewall-cmd -remove interface ENP1S0 zone equals work. And I guess I'll do this in the permanent configuration as well. So permanent. There we go. And of course I should reload after doing that. So firewall cmd reload. And yeah, let's just find out what happens. So if I run a get active zones again, you'll see here that my interface that used to be part of the work zone is now under the default zone, which is DMZ. So when we say remove interface, it's not like it's going to just fizzle out of existence. What we're really doing is just removing the interface's binding to a particular zone. Okay? Alrighty. One more thing that I'd like to tell you about is how the add interface option differs from the change interface option. So both of these options are used to associate an interface to a specific zone, but there are a couple of small technicalities, and especially with change interface, when you use that, it's going to actually remove the interface from the current zone and then add it to the specified zone. So that's what's actually happening in the background. On the other hand, add interface is simply going to try to bind the interface to the specified zone. So in practice, it can be really weird when network manager is involved. So what I really recommend is that you just use change interface whenever you can to really get those interface assignments going. And if you need to, you might need to mess around with the network manager configuration to set the zone, because sometimes it just acts really strange. So how about I just show you that? I'm going to try and add, well, maybe I should do a firewall cmd get active zones. I'm going to try to add my new interface, ENP8S0, to the public zone. Okay, so I'll do a firewall-cmd -add interface equals ENP8S0 zone equals public. And I'll just do that in the normal configuration, not permanent. And let's just try that. Okay, so it says zone conflict. It's already bound to DMZ. So this is just to demonstrate one of the drawbacks of add interface. It's not smart like change interface, where it's deliberately going to try to make sure that interface is assigned to the zone that you want it to be. So there are some niche use cases where add interface might be useful, but I would just recommend change interface. So let's try change interface. Change interface had a success, and now let's check the active zones, and there we go, it worked. So that's actually a bit unexpected for me. Usually it's really wonky in how it works, especially if you get into the weeds of using add interface and remove interface a lot. So let me just show you one more thing. Since this interface, or actually I think it'll start getting weird when I use permanent. So I'll do that. And then I'll reload. So firewall-cmd reload. And we'll check again. Yeah, so now it's starting to get super strange, right? So here's the way to work around that. If you want to get your interface assigned to a different zone and it's managed by network manager, which it is right now, so nmcli show, there's this new automatic connection made for ENP8S0 when I just added it to this machine. So what we're going to need to do is do an nmcli con mod and then the name of the connection. So there it is. And then a connection dot zone, and then we set it to something else like public. That's what I wanted, right? So I'll do that, and then I think it's a good idea to systemctl restart network manager, and we'll also restart firewalld, why not? And now let's try to get the active zones. And there we go. So now it's permanently configured like that, and it's going to work. So, I mean, not everything always works as you want it to. I tried to persevere for this demo and try to show you it. But yeah, I guess it's a bit rough, but there are ways to make sure that it works by using NMCLI if the interface is managed by Network Manager. That's just something you might need to do. Okay, so I guess I'll just throw up something like a man page on screen just so you can see that the order of how the firewall CMD command works when Network Manager is involved, if you're curious about that. But anyways, what we'll do now is just move on to creating a new firewalld zone and trying to use it. Okay, so I'll just switch over to app server 1 for this part. And now, so creating a custom zone is useful when you have a specific set of rules for a group of interfaces or sources, and they don't fit into your predefined zones. So maybe you don't want to mess around with morphing one of your predefined zones into one that suits your needs. So this is why you might want to create a custom zone. So just to show you now, if I run a firewall-cmd list all on my default zone, we can just get a feel for how this machine works. I didn't change it from last time. And yeah, so there are some web services enabled, like HTTP, HTTPS, and 8080. Just wanted to point that out. And moreover, if I do a firewall CMD get zones, that right here we have the standard set of zones, nothing fancy. So now to create a new zone, we'll use the firewall CMD new zone option, followed by the name of our new zone. So I'll just call this new zone custom. And remember to do this in the permanent configuration, otherwise it won't work. And there we go. I'll just run this and I'll reload. There we go. And now if I list the available zones, we can see that the new custom zone is right here. That's good. And I mean, from there, it's really up to you on how you use the zone. We can do something simple like move these services to it. Like, actually, why don't we do that? It sounds like kind of cool. So you can see that these are like some web-related ports and services, and maybe hypothetically you want to restrict your web-related traffic of this server to a specific zone that only allows certain source IP addresses. So I mean, that's oddly specific, but we've been empowered with these tools so that we can do weird things like that. So what we'll do is just remove these services and ports from the current public zone with a firewall CMD remove service equals, and we'll use some brace expansion HTTP, HTTPS, and we have to do that in permanent, and that'll get rid of those from the default zone. And then I'll just do a firewall CMD remove port 8080 TCP in permanent. Cool. And then we'll just add these to the custom zone that we created. So firewall CMD add service and firewall CMD add port. Whoops, I added it back to the default zone. I didn't want to do that. My bad. I need to do add service zone equals custom. And then add port. And that should be 8080 TCP. And that was a little bit of a rough patch, but what we should see now, if I reload the firewall and then do a firewall CMD list all, we'll make sure that this is good. That's good. and then zone equals custom, that my web ports and services are now part of this custom zone. Okay? So adding these to the zone isn't going to make anything significant happen right away. We also need to add a source of traffic to our custom zone in order for things to work the way we want them to. So one option would be to assign an interface to this zone, like we've already played around with. But another option would be to add a source IP address or source network to this zone so that traffic from that source IP or network, regardless of the origin interface, can get handled by our custom zone. So let's do that. Firewall-cmd permanent and zone equals custom, and I'm going to add a source address. So add source equals, and I'll add the IP address of app server 3, so 10.0.0.13. And then remember to reload the firewall with firewall cmd reload. There we go. And now if I do a list all on my custom zone, we can see that the source is now in this settings page. Cool. Now for us to actually see this in action and try it out, I'm going to need to quickly install a web service like HTTPD here and start it up. I'll just do that. Yum install HTTPD -y systemctl enable HTTPD. Yeah, that should be good. So I'll just wait for that. Okay, cool. So now if I go over to app server 3, and I guess like first let's just check that my server is working. Yes, it is. So now if I go over to app server 3, the machine that we explicitly allowed, and I do a curl app server 1, you can see that it's working. We have a successful curl. However, if I do the same thing on app server 2, curl app server 1, it doesn't work. It's not going to work. So I hope I made it clear why that is. We only allowed the source address 10.0.0.13 to reach our web server services on app server 1, right? So yeah, that's why it's working like that. Okay? Now one more thing that I'd like to show you is, I have a couple more things to show you. So this is just how to get a bird's eye view of all of your zones. I guess I should have showed this before, but I'm going to show it now. Firewall-cmd --list all zones. This is going to give you a list all on each of your zones, so you don't need to do it on each one of them if you want to just check all of them out at once. So that's cool. Yeah. So anyways, let's just go and switch back over to app server 3. And I'm going to finish the video off by discussing how to block ICMP traffic. So we can start by just checking out the various ICMP types with firewall-cmd get ICMP types. And there we go. There are a bunch of them, but maybe we want to block something specific like echo. So I'll just rep for echo so we can see it in that list. There it is. And now to ignore this specific type of ICMP traffic, we'll just need to run a firewall-cmd add ICMP block equals echo request. And I guess I'll do it in the permanent configuration. Why not? And now I just got to reload. So firewall cmd reload. And there we go. So now if I run a firewall cmd list all on my default zone, the setting is right here, ICMP blocks echo request. So now I can test this out by just pinging this machine, which does an ICMP echo in the background. And I guess we'll do it from app server 2 this time. So ping app server 3, and it says packet filtered. So there's the blocking in action. Otherwise, we would have seen a more descriptive message come back from the ping. And yeah, so it's working as expected. Similarly, we can also remove the ICMP block with a firewall-cmd remove ICMP block equals echo request. And yeah, I'll just do that and Maybe I'll do it in permanent and reload. Now, if I check list all, there are no ICMP blocks. And now if I try to ping again, we can see that we're getting our normal ping in action. There we go. So there are some more powerful and comprehensive ways to handle blocking ICMP traffic on a larger scale. You can do something like use rich rules and ICMP block inversion. I guess I'll just briefly go over inversion real quick. So you'll see here that on my list all here on app server 3, that ICMP block inversion is off right now, and I have no specific ICMP blocks at this moment. So right now, if I turn on inversion, this is going to tell firewalld to invert its rules with ICMP. So firewall CMD add ICMP block inversion, just like that. And that was a success. And I can demonstrate this again with ping from app server 2. So we're going to get the same packet filtered errors again. However, all ICMP traffic is going to get blocked in this type of way. So yeah, the whole point of this is that instead of automatically allowing all ICMP traffic and then you needing to block specific types, it becomes that firewalld will make all ICMP traffic blocked, and then you'll need to allow specific types of traffic. So this might be useful for some administrators. I just wanted to show you that. And you can take this a step further by changing the target of your default zone to something like drop, so that the blocked connections get nothing but silence in return. So anyways, that's just going to be all for today. I hope this video helped clarify some concepts related to firewalld zones and the ways that we can use them. In a bonus video that I'm planning to make at some point, I'll quickly go over the firewall rules that allow my NAT router in my lab network to work, and how to create custom service definitions. That's kind of extra information. It's not super important. It's just for fun. But yeah, thanks for watching.